Last time we talked about thermocouples, and this time we're going to look at some different instrumentation, different ways to read that thermocouple. These are all type Ks, and say you need a gauge that is matched to the thermocouple type. Here's three basic ones. This one in the middle is you just hook the thermocouple up to these two posts. There's no batteries, no electricity required. It's kind of primitive. eBay for 20 bucks you find them. It has a Fahrenheit and a centigrade scale, and they just work. Sometimes they're called pyrometers, which is the same thing. They measure fire, they measure heat. This one up here on the label, it says thermocouple type C/A, chromel alumel, and that's a type K. So that's how you know what you've got. But say I'm not using those. I don't think anybody else is. So we're just going to look at these two common ones, which I know some of you are using. These little ones here are real nice. They are battery operated. Don't plug into anything. I don't think they can plug into anything. They have two channels, and you can switch from T1. I don't have anything in T2 connection. They take this little miniature thermocouple connector that comes on some thermocouples, or you can buy them with screw terminals and you can put them on yourself. Measures T1 or T2. We're doing T1. It has Fahrenheit, Kelvin, which is another scale, or centigrade. I like Fahrenheit. And they just work. Power switch. You can do a hold function. There's a min-max average function. But say this particular one, again, inexpensive from Harbor Freight. You can do two. With this setting, you either switch between T1 and T2. With this one, you actually do T1 minus T2. I don't know what that would be good for. The thermocouple that actually comes with this one is a real lightweight, but you can see how small a thermocouple can be, and that little knob right on the end is the junction that's welded together. And let's see, I want to get some fire out here so we can see how these things work. This is very small, and being small, you'll see it reacts. Ooh, I got it red hot. Reacts very quickly. There's 1,000, 1,200 degrees, just boom. Something this small, you can imagine you can ruin it just in a matter of a few seconds. And so these extremely thin, small wire thermocouples are not very practical. They cool off. If I wet my fingers, I can get it down to 100, 125, 95. There's just not a lot of mass here. They're lightweight. The insulation is just nylon. It would melt in a minute. So say what comes with it is really not good for any instrumentation that we do, but for some things it would be just fine. Now over here on the this digital one, I have knocked the connection loose. I just got this plugged in here temporary so we can see what's going on. I'm using this L-shaped ungrounded thermocouple. It's reading 90 because I've had it up pretty warm, but this it's a chunk of steel, so if you put it in there, you'll see it reacts a lot slower. I mean, that's fine for what we're doing, and pretty much the tip will do it all. These little readouts here, most of them, this one I've just got plugged into a little DC converter on 9 volts. They work fine at 9, at 12, even up to 15 or more. If I leave that thing in there, I almost get it red hot. I don't know it's starting to glow there. I could ruin it if I left it in there. These I think are rated at 1600 or something. And so, propane is capable of doing a lot. They're starting to get just a little cherry red, about 1300 degrees. Of course, if you take it out, it takes a lot longer for it to cool off because there's a a larger mass there. But it just gives you a nice digital readout. You can tell exactly where you're at. Pretty quick response. You can see it cooling off, and it just works good. These are inexpensive. They hook up to 12 volts. 2 thermocouple leads just plug in. With the 12 volts, it don't make any difference, plus or minus. Electronics takes care of that. Thermocouple, you always have to watch your polarity. Remember, a type K, red is negative, blue is positive. And so that's what I've got hooked up here. But I'm going to take this off and hook up this thermocouple. And there's a wide prong and a narrow prong, so you can't get them wrong. They will only go one way. Get that thing hooked up. Say, this is another type K, the small, inexpensive one. And, you know, they respond pretty quick. A little less mass there. I can get it cherry red, just pretty quick. 1300 degrees. The smaller the mass, the faster it will heat up. And so, see, they work just fine. But if you remember, this is the thermocouple that's grounded. In other words, this sheath is connected to the thermocouple itself. If you take an ohm meter and measure from one of these leads coming into the sheath, you'll read a dead short. So where we get in trouble is we have a 12 volt negative ground system on our vehicles. Well, that minus side of the battery is hooked to the chassis, and when you plug this into your gasifier, this will touch the gasifier will touch the truck, and so you'll end up with the minus 12 volts touching this. So I've got this wire here, it's on the negative 12 of the power supply, and you can see if I touch it to it, it kills it. Because what we're doing, we're basically shorting out the signal. The thermocouple is connected to this sheath. It works just fine if the readout is isolated. But if the readout has a negative 12 volt, which this one does, and that happens to be the common ground of the truck, the vehicle, the chassis, they will not work. And so you're better off to stay away from grounded thermocouples, but I didn't know that. I was late one night and I was fixing up that truck and it wouldn't work, and I couldn't figure out, so I got desperate and put in some individual 12 volt power supplies to power each individual readout. And if you do that, it's a lot of work, but it will work. So that is the problem you run into with grounded thermocouples. Say the only way to get around it is to isolate the 12 volts that power these things. The only way you can isolate them is on a individual converter that you plug into a power strip in your vehicle that's plugged into an inverter in your vehicle that's plugged into the 12 volts. A lot of fussing around, and better off just to go get a good ungrounded thermocouple. So there you go. Buy good thermocouples, cheap readouts, hook it up with the right wire, watch your polarity. You will get good, consistent readouts.